Aloha, and thank you for coming to my tech talk today. My name is Dr. Bryce Davis, and I will be presenting MANA, Oceanit's high-temperature battery separator. Oceanit is a mine-to-market engineering company based in Honolulu, Hawaii. I'm a senior scientist at Oceanit supporting MANA's scale-up and commercialization. After the presentation, if you have any questions or would like to discuss our high-temperature battery separator, please feel free to contact me. I will provide contact details at the end. First, I would like to thank NavAir, our TPOC, Dr. Adam Jolly, and the STP team for their support with this project and granting us the opportunity to present today. Oceanit was established in 1985 and is Hawaii's largest diversified science and engineering company. We have nearly 200 employees and occupy offices and laboratories in Hawaii, Texas, and Washington, D.C. We work on projects in energy, space and defense, ocean engineering, information science, and healthcare, to name a few. Oceanit thrives in delivering solutions from deep science to the market through a process we call intellectual anarchy, solving wicked problems with disruptive innovations. Catastrophic lithium battery fire and explosion failures are a serious concern for end users. Lithium-ion battery safety remains a significant concern as battery failures lead to the ejection of hazardous materials and rapid heat release that can cause propagation from cell to cell, resulting in a total catastrophic failure event. This thermal runaway is the major cause of fire and explosion in lithium-ion batteries. Safer lithium-ion batteries are critical for military aviation platforms and underwater and portable applications. One solution to this problem would be to engineer a better battery separator to minimize the possibility of battery failures. Current battery technologies use polyolefin-based separator technology, which can shrink, melt, crack, split, and burn under extreme conditions. In contrast, separators made of more thermally stable materials can prevent these effects. The expected transition target for us is Navy and Marine Corps Small Tactical Unmanned Air Systems, PMA 263. However, we believe our MANA high-temperature battery separator can be utilized in sea, space, and other battery applications. To overcome the inherent deficiencies in the current polyolefin-based separator technology, Oceanit developed a nanofiber hybrid polymer separator with controllable porosity, conductivity, and excellent thermal stability, up to 250 degrees Celsius. In the top images to the right, you can see the thermal stability of our MANA separator compared to the current state-of-the-art commercially available battery separator. At less than 160 degrees Celsius, the commercially available battery separator completely melted and shrunk, causing a complete thermal runaway failure. In the bottom right image, you can see that our MANA separator is still intact after a complete battery meltdown, while the commercially available separator is completely gone. MANA does not melt and does not catch fire and stays intact even at high temperatures. Oceanit has developed a new class of hybrid polymer separators with controllable porosity, conductivity, and excellent thermal stability up to 250 degrees Celsius for lithium-ion batteries. Still, we believe it can be used in many other types of batteries. Our nanofiber manufacturing method results in a 50% increase in porosity and ionic conductivity. Our new hybrid polymer system has superior thermal stability, durability, wettability, and ionic conductivity over standard tri-layer polyolefin battery separators. We are currently evaluating our battery pack in an operational environment and are excited about the future. We are currently at a TRL 6 and will be at a TRL 7 after completing our current test evaluation. After completing our battery pack demonstration, we plan to pursue a Phase 2E with NavAir. As I mentioned earlier, Catastrophic lithium battery fire and explosion failures are a serious concern for all end users. MANA is a revolutionary battery separator developed by Oceanit in collaboration with the Department of Defense and Department of Energy. The battery separator leverages functional nanofiber manufacturing technology to create a high-performance separator that significantly increases battery safety, reliability, and performance. The primary application is for high rate and high temperature rechargeable lithium-ion and lithium-sulfur batteries. Oceanit's patented nanofiber-based separator technology product features are high temperature melt integrity, which provides thermal stability in extreme environments, up to 250 degrees Celsius. Nanostructured separator with excellent resistance to acids, bases, and solvents. Oxidation resistance for excellent cyclone and trickle charge performance. High porous nanostructure enables rapid wettability and high electrolyte retention. Low electrical impedance and high porosity provides high rate capabilities. After completing our 28-volt, 10 amp hour battery pack demonstration, we plan to move into phase 2E. Plus, at this stage, we will have a more extensive sample set of batteries with our separator, which will allow for a more considerable failure analysis. In phase 2E, we plan to move directly into more technology-filled demonstrations and validation tests. We will also test and evaluate different battery pack configurations and environments. We will target the specifications outlined in the NAVC S9310AQ SAF 010 and MIL PRF 29595, lithium battery specification and program responsibilities. We are looking for high power lithium-ion battery users, and we believe our primary Navy platforms are Unmanned Aircraft Systems, UAS, FA-18F Super Hornet, the F-35 Lightning II aircraft systems, and other DoD agencies with similar battery needs. Advancements in battery power density, energy density, and cost drive market growth across all sectors. Also, government incentives and technology advancement are causing market growth in battery electric vehicles and the space sector due to lowered cost. Safety has been a limiting factor in adopting lithium-ion batteries by the aviation and space industries. Oceanit's advanced separator technology provides a unique benefit to any application requiring a high degree of safety in the commercial sphere. Wearable electronics, tactical devices, unmanned aerial vehicles, and portable electronics are all avenues that Oceanit is exploring. At scale, Oceanit aims to become an industry leader in supplying safer lithium-ion batteries to consumer electronics and electronic vehicles. Oceanit's high-temperature battery membrane can be used with any battery system to increase safety for equipment and personnel. As mentioned earlier, the initial target prime is Unmanned Air Systems, UAS, the FA-18EF Super Hornet, and F-35 Lightning II. Oceanit is pursuing angel funding and manufacturing partners in air, sea, and space battery systems. We are looking to leverage Oceanit membrane technology into other ion selective technologies. Oceanit's high temperature membrane can be utilized in any battery that requires superior safety. Thank you for taking the time to come to our presentation on MANA. As I mentioned, my name is Bryce Davis, and I'm with Oceanit Laboratories in Honolulu, Hawaii. If you have any questions or would like to discuss MANA in more detail, please contact us at the information listed on this slide. This slide contains a copy of our technical data sheet. Please take a minute to review, but if you would like a PDF copy, please contact me or come by my table at the STP booth 537 on April 4th. Thank you again for coming today.